Welcome, geometry students. Today we're going to learn how to find and apply surface area of prisms and cylinders. As a quick reminder, a prism is a polyhedron with two congruent faces, which we call bases. If you recall, we named the prism using the non-rectangular base, if they have one. The lateral faces are all the faces of the polyhedron except the base or bases. The lateral edges are the segments connecting the lateral faces. The lateral area is the sum of the area of its lateral faces. So essentially this vocab, you want to take a quick minute to make sense of it. We've already seen the vocab word prism, so we know that that's a polyhedron with two congruent faces. Might be a triangular prism or an octagonal prism. And then the lateral faces essentially are just all of the exposed sides except the bases. So it's lateral. Lateral edges are the edges on the lateral faces. And the lateral area is the area of the entire 3D object except for the bases. Alright, let's take a look at this formula. This unit's all about surface area and volume. So we're going to learn how to find the surface area of a right prism. So this formula works for a right octagonal prism, a right rectangular prism, a right pentagonal prism, etc. Any base, this works. So the formula is S for surface area equals 2 times the area of the base, big B, capital B, times capital P times H. So big B is the area of the base. Keep in mind, if there's something that's not a rectangle, that needs to be the base. So in this particular picture, it would be the triangle. Capital P is the perimeter of the base, not of the whole 3D object, just of the base. So that's really important. And H is the height of the figure. So that's basically the perpendicular height that connects the bases. If you look here, here's our base. Doesn't matter which one of those two triangles you used. So we would calculate the area of one of those triangles, the perimeter of one of those triangles, and then we would calculate the perpendicular height, which connects the two bases. So let's take a look at an example. Find the surface area of a right prism. This, in this particular case, is a right triangular prism. The key that you want to pay attention to is what the base looks like. I'm going to recommend that you draw just the two-dimensional base. So pretty much everything that we're going to be using is going to be working off of the base. Everything that is except for the height. Then you're going to show your work by writing the formula first. That is a required step so that I know you're using the correct formula and that's not the cause of a mistake if you happen to make one. The next thing I'm going to show you is how I'm going to expect you to show work on everything. Homework, quizzes, tests. So I'm very particular about how you're going to show your work on this, and the reason why that is this method will help you to get the most points on quizzes and tests. So we're going to start by writing the formula, and then we're going to identify the parts of the formula. Well, the first part we need to find is big B, which stands for the area of the base. Well, here is the triangle, and we know that that's the base. So the formula is 1/2 base times height. We're using this formula from what we learned in the last unit. So the area of the base, we continue to label what we're finding with big B, is equal to 1/2 6 times 8. So if we calculate the area of that triangle, it's 24 square units. Then we're going to show our work for calculating the perimeter of the base. Well, in order to calculate the perimeter of a triangle, we need all three side lengths. So we're going to go ahead and use Pythagorean theorem to find the third side length, or C. Go ahead and pause your video to find the length of C. You should have found the length of the third side of the triangle to be 10. If you're not sure how we calculated that, go ahead and take a look at what I just did here. So now we can add the perimeter lengths, or add the lengths of the triangle to find the perimeter. 8 plus 6 plus 10. So we use Pythagorean theorem here. Trig might also come into play, so keep that in mind as a backup plan. We should find the perimeter of this triangle to be 24. Now, I found all of that information while looking at the base of the triangle, because big B and capital P stand for the area of the base and the perimeter of the base. Now I need the height. The height is not the height of the triangle or the base. It's the height that connects the two bases. So this is the only measurement that is not coming from the base, and it's 20 inches. So the height is 20 inches. Now I'm going to use the formula I had put before, and I'm going to fill in what I just calculated. So 2 times the area of the base, which was 24, plus the perimeter, which was also uniquely 24, that was coincidence that those were the same, times the height. You can calculate this to be 528 inches squared. This is still in square units because we are calculating an area. Essentially, we just calculated the area of all the exposed faces, so 3 rectangles and 2 triangles, which is the surface area of our object. The next formula we need to talk about is how to calculate the area of a right cylinder. So again, a cylinder is basically like a pop can. We use the exact same formula as what we just saw in a right prism. And the reason is this formula is useful anytime you have 2 congruent bases, which we have here. These bases just happen to be circles. So keep in mind, big B again is area of the base. Capital P is perimeter of the base. And H is height of the figure. So that's the perpendicular height that connects the length of the bases. Example 2 says to find the surface area of a cylinder. So again, we're going to start by showing the same work as we did prior. Start with your formula and a picture of what the base looks like. So keep in mind your base has to be the non-rectangular side, or excuse me, the non-rectangular face. In this case, it's a circle with a radius of 4 meters. So we're going to show our work and we're going to label every single step so you can get as many points as possible. Well, if we're finding the area of the circle, we're doing the same formulas as we did last unit, pi r squared. So I'm writing the formula first, and then I'm plugging in my information. Well, I'm going to keep this in exact form so I don't have any rounding errors. So the area of this base is 16 pi. Now I calculate the perimeter of the base. And as a reminder, the perimeter of any circle is the circumference, or 2 pi r. So again, we're going to plug in the radius of 4, and in exact form, that makes it 8 pi. If you notice, I've labeled every single step saying that P stands for the perimeter of the base. The last measurement I need is the height. Now everything came off this base measurement except for the height. The height is what connects the 2 bases. So in this case, it's a height of 5 meters. That's the perpendicular distance between the 2 bases. Now I simply use the formula that I began with, and I plug in what I know. 2, the area of the base is 16 pi, plus perimeter of the base or circumference, which was 8 pi, times the height of the figure. Be careful when you plug this in just to make sure you have everything correct. And you should find that the surface area of this cylinder is approximately 226.19 meters squared. All right, example 3 we're going to save for class tomorrow, so just hang on to that. If you feel like trying it, feel free. We're just undoing the surface area formula to find the height, but we will discuss that tomorrow in class. You should try the 2 you try nows, check your answers, and make sure they're accurate. If you have questions, you can bring those with tomorrow. Thanks for joining me, and have a good day.